Okay, so this video we're gonna go over elements and atoms. Okay, so elements are made of tiny indivisible particles called atoms. Okay, so you have an element, and that element has little pieces inside of it called atoms. All of these atoms are not separate parts of the elements; they're the same part. It's just that an element can only be broken down into a certain amount, and that tiny portion that it's broken down to, it's called the atom. Okay, so then we have an English school teacher named Dalton who proposed a theory about atoms. Atoms are indivisible parts of matter. So for instance, if you were to get let's say, I don't know, a pencil, and you were to break the pencil again and again and again and again until finally you can't break it anymore, and it's such a small piece, then that is called the atom. You cannot see an atom with the naked eye, and you cannot see an atom with a microscope. So atoms are very, 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 very tiny. So just imagine you trying to break something until the point where you just can't break it anymore. Well, it's even smaller than that. Okay, so now let's talk about Dalton's atomic theory. First of all elements are composed of atoms, so you need a periodic table for this review. So if you have one, take it out. If you don't, grab one. So here I have one type of element, and these blue dots represent atoms. So this element has atoms. It's composed of atoms, and these atoms are different from the atoms of another element. So if this is element 1 and this is element 2, their atoms are actually different. Okay, these atoms are blue, these atoms are purple. So that says all elements are composed of atoms, and atoms of the same element are identical. Atoms of different elements can combine. Okay, so I can get the atoms from element 1 and I can get the atoms from element 2, and I can put them together and they can combine chemically to form a new compound. Atoms of one element never change to atoms of another element during chemical reactions. So for instance, the atoms for element 1 cannot change into the atoms of element 2 during a chemical reaction. They can only combine together. So if I get the atoms of element 1, which let's say that this is hydrogen. Okay, so let's say that the atoms of element 1 are hydrogen atoms, and let's say the atoms of element 2 are oxygen atoms. We can actually get these two elements, put them together, and form a compound called H2O, and this is water. Okay, so water is made from one oxygen atom and two hydrogen atoms. Okay, so that's Dalton's atomic theory. Now let's move on to what an atom looks like. Now there are several depictions of an atom. This here is the way that I like to draw atoms, where this circular thing at the center, this is called the atomic nucleus. Let me write it down here. The atomic nucleus. Okay, so this is the atomic nucleus, and inside the atomic nucleus of, by the way, this whole entire thing is an atom. Now, inside the atomic nucleus, the atom has particles, and they're called subatomic particles. So in here, you have two kinds of subatomic particles. You have a subatomic particle called a proton, and you have a subatomic particle called a neutron. Okay, so these two subatomic particles are inside the atomic nucleus. Okay, now outside of the atomic nucleus are these yellow subatomic particles, and those are called the electrons. Now electrons go around the nucleus of the atom, and they go very, very, very fast. So electrons are very fast, and these circular paths that I drew, these paths are not actually there. I just drew them to kind of show you that the electron travels in this circular path. Okay, so these paths don't actually, this is not part of the atom. This is just where the electron circulates around the atomic nucleus. Okay, so now let's go into how much these subatomic particles weigh. They're actually weighed in a special type of unit called the atomic mass unit. And protons and neutrons weigh almost the same thing. Notice that the proton weighs 1.0073 atomic mass units, and neutrons weigh 1.0087 atomic mass units. So protons and neutrons weigh almost the same thing. Electrons, on the other hand, we say that they weigh nothing. We don't take their weight into account because their weight is very, very tiny. Electrons weigh 0.00055 atomic mass units. So this is very, very tiny compared to a proton and a neutron, which are the things that actually weigh. Another thing that I want to mention is that this figure is not drawn to scale. And what I mean by that is that, for instance, if a proton were this big, okay, so let's say a proton were this big, this is the proton, then the electron would probably be this big. Okay, so electrons are very, very, very tiny compared to a proton and a neutron, and this is why they weigh so little. Okay, so aside from that, protons and electrons have a charge, and this is what produces electricity. Protons have a positive charge, okay? Protons have a positive. You can remember P for positive. Electrons, on the other hand, have a negative charge, okay? Electrons have a negative charge, and protons have a positive charge. Neutrons have no charge. Okay, so neutrons are neutral. That's how you can remember. Neutrons, neutral. Protons, P for positive, and electrons are negative. Okay, so let's go down here. J.J. Thomson discovered the electron, so this is just a little bit of history if you want to know about it. E. Goldstein discovered the proton. James Chadwick discovered the neutron. Okay, so these are the three people that discovered the subatomic particles inside the atom. And finally, we have another guy, his name is Rutherford, and he proposed the atom is mostly empty space except for the dense region where protons and neutrons are found. He called this the nucleus. Okay, so I mentioned already that the center is called the atomic nucleus, and what Rutherford said is that the nucleus is where all the weight of the atom is. Remember that protons and neutrons carry the weight of the atom, so all the weight is here in the center. Electrons are negligible, so they have barely any weight. So that's why he said that the outside of an atom is mostly empty space. Okay, let's see. Every element has a certain number of protons, and that is called the atomic number. So the atomic number tells you the number of protons. So let's count. Let's say that purple is the protons. Okay, so we have 1, 2, 3, 4, 5, 6. So this atom has 6 protons. That is the atomic number of this atom. Okay, so atomic number is the number of protons. And one thing that I want you to notice is that the protons in an atom have to equal the number of the electrons. So if you have 6 protons, notice you're going to have 1, 2, 3, 4, 5, 6 electrons. Okay, so if you have 6 protons, you're going to have 6 electrons, because remember that protons and electrons are the electricity. So in order for them to be neutral, you need to have the same amount so they can cancel each other out. Okay, and the last thing that I'm going to talk about is the atomic mass. The atomic mass is how much the atom weighs. Okay, so this atom is actually, if you look at the periodic table, the atom that has 6 protons is carbon. So this atom that I drew is a carbon atom, and this carbon atom has a weight of 12.011 atomic mass units. This is how much this atom weighs. Okay, so this concludes this video.